Hi everyone, welcome to our class. This is the third part of our discussions about sets, and this time I am going to discuss about Venn diagram. The Venn diagram is also known as Venn-Euler diagram in honor of Leonard Euler and John Venn, who first found this diagram in representing relationship of sets using rectangles and circles or oblongs. So a rectangle is used to represent the universal set, and circles or oblong represent subsets. Overlapping circles show sets having common description, while circles that do not overlap do not have common shape. Example, we have in here a diagram showing two sets A and B. So looking at the sets A and B do not intersect. That means they do not have any element having common description. And so therefore, A and B are disjoint sets. Another Venn diagram in here shows sets A and B which are intersecting. So since they are intersecting sets, this region in here showing the overlapping part of set A and B shows the elements having common descriptions or elements in A and B having common descriptions. And we call this area in here or region in here as A intersection B. While this region in here, these are elements in A which are not found in B. While this region are elements in B which are not found in A. A Venn diagram helps us to visualize information about different sets. In the diagram, we see their similarities and differences. You look at the diagram below. If you are in search of an apartment or a boarding house, you can start by looking at what each can offer to their tenant. Draw a Venn diagram so that you can compare them. So this diagram is giving you a clearer picture of what they offer and choose the most convenient apartment that best fit to your need. Here is a problem. Illustrate the following sets in a Venn diagram. Given the universal set whose elements are the counting numbers 1, 2, 3, 4, 5, 6, 7. Subset A has elements 2, 3, 7. B has elements 2, 3, 4, 5. And C has elements 1, 2, and 4. And we are required to find A intersection B, B union C, B minus C, B intersection C intersection A, and the complement of B. So we start by drawing the Venn diagram. So we have here a rectangle showing the universal set U. Then, before you draw the subsets, try to look at first the elements in the given set. Try to find out if the sets are intersecting. Set A has elements 2, 3, 7, B has elements 2, 3, 4, 5, and so obviously, since they have common elements, then they are intersecting sets. B has elements 2, 3, 4, 5, and C has elements 1, 2, 4, and since they have common elements 2 and 4, therefore, B and C are intersecting sets. A and C has common element 2. Therefore, we say the three sets are intersecting sets. So this is how we draw three intersecting sets represented by this oblong. So we have here sets A, B, and C are intersecting sets. When you draw now the elements inside the oblongs, you start with the element or elements which are common to the three sets. So in here, notice that 2 is common to the three elements. So looking at the diagram, this is the area or this is the region common to the three sets. So this is where you're going to write the common element 2. And then we now go to the intersection between two sets. So between A and B, between set A and set B, they have common elements 2 and 3. So since there is already an element 2 common to A and B, so this is the region showing the intersection between A and B. So since there is already this common element to A and B, which is 2, so the remaining common element to A and B is the element 3. So you write that one in the region showing the intersection between A and B. Then let us go to now the intersection between B and C. So B and C has common elements 2 and 4. The area or the region showing the intersection of sets B and C is this area. And the common elements are 2 and 4. Since we already have a 2 in here, so we need to write in there 4. Okay? So, intersection between A and C, we only have this element 2, which is already found in here. And so we now go to set A. Set A has elements 2, 3, 7. So this whole yellow represents set A. And written in there are elements 2 and 3. What is lacking is 7. So you write in there 7. In set B, you have 2, 3, 4, 5. We already have in the set B, in the blue oblong, we have now the elements 2, 3, and 4. And what is lacking is 5. So write outside the intersecting areas the element 5, which is part of set B. Then set C has elements 1, 2, and 4. We already have in here 2 and 4 in the violet oblong. So what is lacking is just the element 1. So we write 1. Now looking at the universal set, it contains the numbers 1, 2, 3, 4, 5, 6, 7. If we look at the elements found in sets A, B, and C, we only have in here 1, 2, 4, 1, 2, 3, 4, 5, and 7. 6 does not belong to any of the sets. So you write 6 outside the circles but inside the universal set. Okay, so we are now ready to perform the required operation. A intersection B, we are referring to A intersection B, so we are referring to this region. It shows elements 3 and 2. B union C. When we say B union C, we are referring to all the elements which are found either in B or in C. So you're going to collect all the elements found in these two sets. So we therefore have elements 1, 2, 3, 4, and 5. B minus C are elements in B. Elements in B which are not found in C. Okay, so elements in B which are not found in C are the elements 3 and 5. B intersection C is, as we look at the diagram, B intersection C is we have this region. It contains the elements 2 and 4. And then intersection A, so these elements 2 and 4, intersection A, our A contains the elements 2, 3, and 7. So intersection of this and A, we have the element 2. Complement of B is, again, these are elements in U which are not found in B. So as we look at our diagram, all the elements in B are 2, 3, 4, and 5, and what the elements which are found in the universal set but are not found in B are the elements 6, 7, and 1. We have here a problem. There are 3 student organizations, A, B, and C. 40 students were asked if they belong to any of these organizations, and the following data were gathered from the survey. 4 belong to B only, 20 belong to C, 25 belong to A, 3 belong to A and B, but not to C, 5 belong to A and C, but not to B, 12 belong to C, but not to B, 16 belong to A, but not to B. Using a Venn diagram, we are required to determine the number of students who belong to C only, those who do not belong to C, those who belong to B and C but not to A, those who belong to students who belong to exactly one organization, and those who do not belong to any of these organizations. So we start with drawing the Venn diagram. We have here the rectangle representing the universal set, and let us try to find out if the three sets are intersecting. So we have here a statement that there are students who belong to A and B. That means sets A and B are intersecting. A and C are also intersecting. Then we are required in here to determine the number of students who belong to B and C. That means the three sets are intersecting. So let us use a yellow circle to represent organization A, the blue circle to represent organization B, then the violet circle to represent the organization C. So we have here given 4 belongs to B only. Looking at the diagram, this region in here represents those who belong to B only. So there are 4 students who belong to this region. And then you go to those statements giving us intersections between the sets. We have here 3 belong to A and B but not to C. So the region representing those who belong to A, which is yellow, and B, which is blue, but not to C, we are referring to this region. And there are 3 students in this region belonging to A and B, but not to C. The next data is there are 5 students who belong to A and C, but not to B. So A is yellow, C is violet, and so we are referring to this region, students belonging to A and C but not to B. And there are 5 students. 12 belong to C but not to B. So we are referring to this region. This is the region representing students who belong to C but not to B. There are 12 of those students. We already have 5 in this region. That means there are 7 students in the other region. 16 belong to A but not to B. So the yellow circle is A, organization A, and those who belong to A but not to B is represented by this region. We already have 5 students in the list. That means the remaining students who belong to A in this region will be 11. Then we have 20 belong to C. We look at the violet circle. There are still these 2 areas in here where the remaining of the 20 might fall. So we go to the next statement. 25 belong to A. We look at the yellow circle. We already have in here 5, 11, that's 16, plus 3, that's 19. So if there are 25 students belonging to organization A, that means in this region we have 6 remaining students. And that will give us now in organization C, there are 20. We have here 7, 5, that's 12, plus 6, 18. That means in this remaining region, there are 2 students. Now, it is given that we have 40 students. So let us try to count how many students belong to any of the organizations. So we have here 11 plus 5, that's 16. 16 plus 7 is 23. 23 plus 6 is 29. Plus 2, 31. 34, 38. That means there are 2 students who do not belong to any of the 3 organizations. Okay, so let us now answer the following questions. How many students belong to C only? So looking at the diagram, 7 students belong to C only. How many students do not belong to C? So if there are 20, we have here 7, 5, 6, and 2. This is 20. If there are 20 students belonging to C, that means, and there are 40 students, that means there are also 20 students who do not belong to organization C. Next is, how many students belong to B and C but not to A? So the region representing B and C but not to A, it's this region, but do not belong to A. So that means there are only two two students. Then next, how many students belong to exactly one organization? So we look at those number of students who belong to one organization only. We have here 7 plus 11, that's 18. Plus 4, we have 22 students belonging to exactly one organization. How many students do not belong to any of these organizations? So we have here 2. So using a Venn diagram, it will give us a clearer idea as to where the elements, in what particular set the elements belongs to. Okay? Okay, so we end up our discussions in here about sets. Thank you for watching.